This lesson is going to be about the periodic table groups and learning to be able to draw the Lewis structure of an atom and identify the ion forms. In the last video, we learned how to draw the Lewis structure of atoms, and now we're going to be working on identifying the ions it forms. They are going to follow a pattern very similar to the Lewis structures we worked on in the last video. When we learned how to draw Lewis structures, we saw there's a pattern here. We saw that in the same column, elements have the same number of valence electrons. Their Lewis structures look the same. When I have this column right here, this first one, all of their Lewis structures look something like this with one dot, and they have one valence electrons. In the second column, there's two valence electrons. In the third column, there's three. In the fourth column, there's 4, 5, 6, 7, 8, so on and so forth. My sixth one, if I have oxygen, I have 1, 2, 3, 4, 5, 6 valence electron, and this would be my Lewis structure. And all of the elements in that column would look the exact same with this. And our valence electrons are important because they're the ones that affect the chemistry of the atom. They're the easiest to remove, and that's where additional electrons are going to be gained, is in that outer shell of electrons. And so they're the ones that we really want to keep track of, and they're the ones that are going to affect the ions that these elements form. And so you should feel pretty comfortable drawing Lewis structures by this point. You should know how many valence electrons there are in each column of the periodic table and be able to recognize that pattern. Before we start talking about what ions these atoms are going to be forming in the elements, we're going to talk about the difference between fluorine and neon because it's going to illustrate a really key point here. Fluorine has 9 electrons and neon has 10 electrons. They're right next to each other on the periodic table. Right? Fluorine is very reactive. Right? Neon is a part of the noble gases. And if you remember, the noble gases really don't react with anything. They don't do a whole lot. Now, the difference between these two is only 1 electron. But if you look at their outer shells, neon has a completely full outer shell. It has 1, 2, 3, 4, 5, 6, 7, 8. If I was going to add another electron to neon, I would have to make a whole nother electron shell for this. Right? That's something that the atom is very unlikely to do, to add a whole nother shell for this. These atoms are very stable when they have a full outer shell, which neon does. And all of our noble gases do. You saw they all have 8 valence electrons. Remember that 8 electrons is how many can fit into those shells. And so in order to add another electron, we would have to add a whole other shell, which is not something that we're likely to do. If we have fluorine here, fluorine has 7 electrons, and it's only 1 electron away from having a full outer shell like neon. Right? And so fluorine is very, very likely to grab an electron from some other atom and add it to its outer shell so that it can get to the point where it's not so reactive, it's more stable that way. Right? And so fluorine, with its 7 valence electrons, 1, 2, 3, 4, 5, 6, 7, is very likely to add another electron in order to get to the point where it is stable like neon and it has 8 electrons in its outer shell. And that's the main point that you want to think about when you're trying to figure out what ions these atoms form, is that atoms are most stable when they have a full outer shell of electrons, when there's not just 1 electron or 2 electrons or 6 electrons or 7 electrons in that outer shell. They want to have that full 8 electrons. That's something called the octet rule, and that's going to guide what we're doing here. So in the last example, I was showing you how atoms could gain electrons to get a full outer shell. Like fluorine had 7 electrons, and it was going to gain the 1 to get 8, fulfill the octet rule. The opposite can be true if an atom doesn't have very many electrons in its outer shell. If you look at sodium right here, sodium has the Lewis structure right here. It has 1 valence electron. Underneath this 1 valence electron, there's a full outer shell here. This one right below is completely full with 8 electrons. And so sodium could do 2 things here. Sodium could gain 7 electrons to fill its outer shell and have 8. Or sodium could get rid of 1 electron. That would get rid of the need for this shell on the outside here, and sodium would be left with a full outer shell of 8 electrons right underneath it, and sodium would be stable. Right? So what sodium does is sodium gets rid of this 1 electron in order to do that. Right? Now, I didn't talk about this in the fluorine and neon example, but remember that sodium has 2, 8, 11 protons here. Right? So sodium has 11 protons, which have a positive charge. It starts off with 11 electrons, but if it loses that 1 electron, now it only has 10 electrons. Right? Well, if we have 11 positive charges and 10 negative charges, now what I'm left with is a positive 1 charge. And so when sodium gets rid of that 1 electron to fulfill its outer shell in the octet rule, it ends up having a positive 1 charge. And so sodium forms a 1 plus ion. This is typically how we'll write this one, is we'll write Na 1 plus, or we'll just write Na plus to show that there's a 1 there. Now I'm going to show you another example here. You can see beryllium here has 4 electrons. It has 2 electrons in its inner shell, but remember that that inner shell can only hold 2 electrons, and so it's actually full and stable in that way if there was only those 2. Helium is completely stable and it only has 2 electrons because it only has that inner shell. Now, beryllium has 2 electrons in its second shell here. And so beryllium has a couple of choices. It can either gain 6 electrons or it can lose 2 electrons to get to a full outer shell. And these atoms are going to take the path of least resistance here. So it's going to be more likely, actually it's not going to gain 6. It's going to get rid of 2 electrons, right, in order to drop down to a full outer shell right here and look like helium. And so when beryllium gets rid of 2 electrons, beryllium is going to form a 2 plus ion, right? It's still going to have 4 protons. Now it's only going to have 2 electrons because it got rid of 2, and so it's going to have a 2 plus charge. Okay, another way that you can remember what charge this thing is going to be at is that these atoms start off as neutral. They have no charge. They start off at 0 for charge. They lose negative 2 electrons. And if I subtract a negative number, I end up with 2 plus. If you're more of a mathy person, you want to remember it that way. But beryllium is going to form a 2 plus ion, and sodium is going to form a 1 plus ion. If we wanted to go back, and now that we know about the charges and we wanted to review, well, fluorine has 1, 2, 3, 4, 5, 6, 7. We said that fluorine was going to gain 1 electron, because remember, it can either gain 1 electron or it can get rid of all 7 and drop down. And so fluorine forms a 1 minus charge, and so fluorine forms a 1 minus ion here. So if we wanted to go back and now we wanted to figure out, using our Lewis structures, what type of ions these are going to form, we can do it in this way. If we remember that noble gases aren't going to react because they have a full outer shell, so these in this column, I'm going to be going by columns now, are no ions. They're not going to form ions. They're not going to gain or lose electrons. They're perfectly fine the way they are, not reactive. And now we can look at whether atoms are going to gain or lose electrons, and if so, how many. So if we look at in this column, column number 1, remember they have 1 valence electron, so they are going to lose 1 electron. They're going to get rid of that 1. In this column right here, they can either gain 6 or they can lose 2, and so they're going to lose 2 E minus. This column here can either gain 5 or it can lose 3, and so they're going to lose 3 E minus. This column right here is a little bit tricky because it has 4, so you could say, well, it's either going to gain 4 or it's going to lose 4. In all reality, these aren't going to form ions. No, these are most likely going to form covalent bonds, and so they won't form ions. So don't worry about this 4th column right here. In this column, these have 5 valence electrons. So they can either gain 3 or they can lose 5. And so these are going to gain 3 electrons. They're going to bring in those 3. These ones here have 6 electrons, valence electrons, so they can either lose 6 or they can gain 2, and so they're going to gain 2 electrons. In this column here, they're going to either lose 7 or they're going to gain 1 electron, so they're going to gain 1 electron. So we can look at what type of ions are formed by each of these. This is going to be a 1 plus ion. We lost 1 electron, so we now have a positive charge. These are going to form a 2 plus ion. These ones are going to form a 3 plus ion. These ones are no going to form an ion. These ones are going to form a 3 minus, because now we're gaining 3 electrons. 3 are coming into our atom. We're gaining a negative charge. Now these ones are going to form a 2 minus charge, and these ones are going to form a 1 minus charge. So that's how we can figure out what ions are going to form from those columns in the periodic table. So the last step, just to help you out here, you might want to make some changes on your periodic table. You have your groups labeled as 1, 2, 3, 4, 5, 6, 7. You might want to add right above this. I'll show you an example. Oops, if I can zoom in. I might want to add right in here, these form a 1 plus ion, and these form a 2 plus ion. And I might want to go over and say these are a 3 plus ion. These are not going to form right here. These are going to form a 3 minus charge. These are going to form a 2 minus charge, and these are going to form a 1 minus charge. You might want to add that onto your periodic table, so you've always got that with you, and you can always remember what types of ions form from the groups in the periodic table. And remember that the ions formed is going to be determining what the chemistry is, and so that is why elements in the same group have very similar chemical properties. They have the same number of electrons they're trying to gain or lose, and so they act very similarly in chemical reactions. So I hope this video has helped understand the chemistry of the groups of the periodic table.